Section 4.5, Applications of Systems of Linear Equations in two variables. On page 173, let me do problem number 2. If one number is 3 times the other, and their sum is 16, find the number. Okay, so you should note that these problems are nearly identical to what we did back in Chapter 2. The only difference is that rather than setting these up as equation with one variable, we can set this up as a system of equations, and it'll actually be easier to set these up if I am allowed to use more than one variable. So if one number, I'll call it x, or let me call it y, is 3 times the other, and so the other number I'll call x. And so if one number y is 3 times the other number x, and their sum is 16, then find the numbers. And so I'll use a substitution, I guess, in this case. I'll replace y by 3x. And so I get that x plus 3x, 4x, is 16. Divide both sides of my equation by 4. So I get that x is 4. Well, if x is 4, then 4 plus y is 16. Let me subtract 4 from both sides of my equation. And so I get here that y is equal to 12. And so the two numbers are 4 and 12. So I notice that 12 is 3 times as large as 4, and the sum of 4 and 12 is indeed 16. Let me do problem number 4. So as you notice that really solving this system is no more difficult than it would be to solve a system, just one single equation rather than a system. And it is easier to set up these these problems as a system as opposed to just a single variable. Number 4, the sum of 2 times of two numbers is 8. And the difference is 2. Find the numbers. So again, let me set this up. So I have here my first equation. The sum of two numbers, I guess I'll call them x and y, is 8. And their difference, well, x minus y, is 2. So let me add these equations. And so the y's cancel. So I get 2x is equal to 10. Divide both sides of my equation by 2. So x is 5. Well, if x is 5, then 5 plus y is equal to 8. Subtract 5 from both sides of my equation. And so y is equal to 3. And so the numbers are 5 and 3. You notice that the sum of these two numbers is indeed 8, and their difference is indeed 2. Let me do problem number 6. A horse and 2 cows together cost $680. Find the cost of a cow and a horse if the horse cost $80 more than a cow. Okay, so let H be the cost of a horse in dollars and C the cost of a cow in dollars. Then we have 1 horse plus 2 cows is $680. And we have that the horse cost $80 more than a cow. Okay, so let's substitute S into H into R. And so wherever I see an H in the equation for R, I'll substitute for H 80 plus C. Combining like terms, I get 80 plus 3C is equal to 680. Subtract 80 from both sides of my equation. And so I get that 3C is 600. Divide both sides of my equation by 3. And so C is equal to 200. And from equation S, I get that H is equal to 80 plus C. And so the cost of a horse is 280. And so I have that a horse costs $280 and a cow costs $200. And so note that if you had 2 cows, that would be $400 plus 1 horse, that'd be an additional $280. So it would be a total of $680. Good. And a horse costs $80 more than a cow. 280 is indeed 80 more than 200. Let me do problem number 8. A pile of 80 coins consists of nickels and dimes, the total value of the coins is $7.70. Find the number of each type of coin. Okay, so let N be the number of nickels and D the number of dimes. And so I have that the total number of nickels plus the number of dimes is 80. There are a total of 80 coins. Next, each nickel is worth 5 cents. And so if you have N nickels, then they're worth a total of 5N cents. Each dime is worth 10 cents. And so the total value of dimes is 10D cents. And the total value of the number of dimes plus the number of nickels is 770 cents. And so I wrote this in cents rather than in dollars. And so $7.70 is the same as 770 cents. Let me multiply my first equation by -5. And then add to the second equation. $5N minus 5D is -400. So let's add that to S. 5N plus 10D is 770. And so I get that the 5N's cancel. 10D minus 5D is 5D. 770 minus 400 is 370. Let me divide both sides of my equation by 5. And so D is equal to 74. And so from equation R, I get N plus D, 74 is 80. And so N is 6. And so you have here that we have 6 nickels and 74 dimes. Notice that the total number of coins is 80 coins, and 74 dimes is the same as $7.40. 6 nickels is another 30 cents. And so that's a total of $7.70, which is what we wanted. Let me do problem number 10. The total cost of 8 buckets and 5 mugs is $92. And the total cost of 5 buckets and 8 mugs is $77. Find the cost of 1 bucket and 1 mug. So I want to find the cost of 1 bucket, and I want to find the cost of 1 mug. Okay, so let B be the cost of a bucket in dollars. Let M be the cost of a mug in dollars. And so the cost of 8 buckets and 5 mugs is $92. Whereas the cost of 5 buckets and 8 mugs is $77. Okay. So let me multiply the first equation by 5. And so if I do that, I get 40B plus 25M is equal to 460. Let me multiply the second equation by -8. And so I get -40B minus 64M is equal to -616. Let's add. And so the 40B's cancel. -64M plus 25M is a -35M. -616 plus 460 is a -156. And so dividing both sides of my equation by -39, I get that, I get that M, is equal to 4. And, 8B plus 5M is equal to 92. And so subtract 20 from both sides of my equation. So I get 8B is equal to 72. Divide both sides of my equation by 8. So I get B is equal to 9. And so the cost of 1 bucket is $9. And the cost of 1 mug is $4. Let me do problem number 12. 5 books and 7 pens together cost $79, and 7 books and 5 pens together cost $77. Find the total cost of one book and 2 pens. So let's do that. So let B be the cost of a book in dollars, so 5 books, and let P be the cost of a pen in dollars, plus 7P is 79. 7B, 7 books and 5 pens is $77. So let me multiply the first equation by 7. And so I get 35B plus 49P is equal to 7 times 79, 553. Let me multiply the second equation by negative 5. So you get negative 35B minus 25P is equal to negative 385. So if I add these together, the 35B's cancel. 49P minus 25P is 24P. 553 minus 385 is 168. Let me divide both sides of my equation by 24. And so P is equal to 7. Let me plug that into R. And so the 5 pens cost $7 each. And I have plus, oops, these are pens. These are pens. Let's do S, I guess. The 7 books plus the 5 pens, which cost $7 each, is $77. And so 7B plus 35 is 77. Let me subtract 35 from both sides of my equation. And so I get the 7P. 7B is equal to 42. Let me divide both sides of my equation by 7. So I get that B is equal to 6. And so a book costs $7. No, $6. And a pen cost $7. Oh, but we didn't want that. So they want the cost of one book and 2 pens. And so one book is $6. Each pen is $7. So 6 plus 14 is $20. And so one book and 2 pens cost $20. And that is your answer. Let me do problem number 14. A father is 3 times as old as his son. After 12 years, his age will be 2 times the age of his son. Find the present ages. Okay, let F be the age of the father in years, the present age of the father in years. Let S be the present age of the son in years. Then the father is currently 3 times as old as his son. After 12 years, the father's age will be, well, F plus 12. The son's age will be S plus 12. After 12 years, his age, the father's age, will be 2 times as old as his son. Okay. Let me simplify S. Let me multiply the 2 inside the parentheses. So I get 2S plus 24. Let me substitute for S, for F, 3S. And so 3S plus 12 is equal to 2S plus 24. Let me solve for S, so subtract 2S, 12 from both sides of my equation. And so S is equal to 12. And so F is 3 times F. And so F is 36. So the present age of the father is 36 years old, and his son is presently 12 years old. And so, indeed, the father is 3 times as old as the son. After 12 years, well, the father's age will be 48, the son's age will be 24, and so after 12 years, the father's age indeed will be 2 times the age of his son. Let me do problem number 16. Five years ago, John was 3 times as old as Lisa. And 10 years later, John shall be 2 times as old as Lisa. What are the present ages of John and Lisa? Okay, so let's do this. So let J be the present age of John in years. Let L be the present age of Lisa in years. So 5 years ago, John, of course, was 5 years younger. And of course, Lisa was 5 years younger also. And so 5 years ago, John was 3 times as old as Lisa. $10 later, so 10 years later than that 5 years, John will be 2 times as old as Lisa. Okay, so let's simplify each of these. So multiplying 3 inside the parentheses, subtracting 3L, subtracting 5, I get that J minus 3L is negative 20. Let's simplify S. J plus 5. Wait. That was an error. That was an error. That was a minus from R. So this will be a plus. And so this is going to be a minus 10. Oops. That was an error. Okay, so let's multiply the 2 inside the parentheses. So I get 2L plus 10. Subtract 2L from both sides. Subtract 5 from both sides. And so I get J minus 2L is equal to 5. Okay. So let's multiply R by -1 and add to S. So you get a negative J plus 3L is equal to 10. So let's add these up. And so I get L is equal to 15. Let's figure out what J is. So let's use S. And so I get J minus 2L is equal to 5. And so J minus 30 is 5. Adding 30 to both sides of my equation, I get J is equal to 35. Okay. And so John is 35 years old. Oops. He's 35 years old. And Lisa is 15 years old. Okay. Right, so 5 years ago, John was 30 and Lisa was 10. And so John was 3 times as old as Lisa. And so he was 30 and she was 10. After 10 more years, he'd be 40 and she'd be 20. And so John would be 2 times as old as Lisa. Let me do problem number 18. A man invested $3,500. Part of it at a yearly interest rate of 4%, and the rest at 5%. He received a total annual interest of $153. How much did he invest at each rate? So let X be the amount invested in dollars, of course, at the 4% interest rate, and let y equal the amount invested in dollars at 5%. Okay, so he invested a total of $3,500. He received 4% interest rate per year from his first investment and 5% interest per year from the second investment to get a total of $153. And so let's multiply S by 100. So I get 4x plus 5y is equal to 15,300. Let me multiply the first equation, by -4. And so I get negative 4x minus 4y is equal to negative 14,000. And so let's add these together. So I get that y is equal to 15,300 minus 14,000. So 1,300. And let me determine what x is. And so I have that x plus y is 3,500. Let me subtract 1,300 from both sides of my equation. And so I have that x is equal to 2,200. Okay. And so you should invest $2,200 at 4%, and you should invest $1,300 at 5%. And that is your answer. Let me do problem number, that was 20. Let me do problem number 20. The perimeter of a rectangle rectangular plot is 32 meters. If the length is increased by 2 meters, and the width is decreased by 1 meter the area of the plot remains unchanged. Find the length and the width of the plot. Okay, so first remember that, let L denote the length of the rectangle and W the width of the rectangle in meters. Well, we know that the perimeter is twice the length plus twice the width, and the area of a rectangular plot is the length times the width. So it says, let's do R. So it says that the perimeter is 32 meters. So I have that the perimeter is 32 meters. And if we increase, if the length is increased by 2 meters, and the width is decreased by 1 meter, then the new area is the same as the old area. And so this is the new area, and it should be the same as the old area because the area remains unchanged. Well, let's simplify this. So first, let me multiply out S. So I get LW minus L plus 2W minus 2 is LW. Let me subtract LW, and let me add 2 to both sides of my equation. And so I get negative L plus 2W is equal to 2. And for R, let me multiply by negative 1. I'll have a whole bunch of negatives, but that's okay. So I have negative 2L minus 2W equals negative 32. Let me add. So I get negative 3L is equal to negative 30. Divide both sides of my equation by negative 3. And so L is equal to 10. And well, let me look at S. Negative L plus 2W is 2. So let me add 10 to both sides of my equation. So I get that 2W is equal to 12 divided by 2. So W is equal to 6. And so I have the length is 10 meters and the width is 6 meters. Notice that the area of, well, that the perimeter of this would be 16 plus 16 is 32. Good. And the area is 60. But if you increase the length by 2, so it's 12, and decrease the width by 1, that's 5. 12 times 5 is 60 also. So it actually doesn't change the area if you increase the length by 2 and decrease the width by 1 meter. Let me do problem number 22. In a parallelogram, one angle is 4/5 of the adjacent angle. Determine the angles of the parallelogram. Okay, so, well, one angle, maybe I'll call it Y, is 4/5 of the other angle. And the sum of the angles of a parallelogram are 360. So 1x plus 1y plus another x plus another y is 360 degrees. Let me do substitution, I guess. Doesn't really matter. And so let me substitute for y into s. So I have 2x plus 2y is 360. And so I have that 2x plus 8/5 x is equal to 360. Let me multiply both sides of my equation by 5. And so I get 10x plus 8x. The 5's cancel is equal to 1,800. So 10x plus 8x is 18x is equal to 1,800. Let me divide both sides of my equation by 18. So x is equal to 100. Well, let's figure out what y is. And so y is equal to 4/5 times x. Well, 100 divided by 5 is 20 times 2 is 80. Okay. And so, if I look here, the angles of the parallelogram are 80 degrees, 100 degrees, okay, and so those are the measures of your angles of your parallelogram. They're each, well, Wait. Yeah, so that's 100 degrees, and that's 80. Okay, and so that gives you your four angles, and so uh, 80 is 4/5 of 100. So the adjacent angle is 4/5 of the other. One of the adjacent angles is 4/5 the other. Let me do problem 24. The semiperimeter of a rectangle is 33 centimeters. And the difference between the length and the width is 3 centimeters. Find its length and width. Okay, so let L be the length of the rectangle in centimeters, W be the width of the rectangle in centimeters. And so the semiperimeter is 33 centimeters. And the difference between the length and the width is 3 centimeters. So let's add these. So I get that 2L is 36. Divide both sides of your equation by 2. So L is 18. And so let's use R. So 18 plus W is 33. Subtract 18 from both sides of my equation. And so W is 15. So the length is 18 centimeters and the width is 15 centimeters for this particular rectangle. Let me do problem number 26. A man starts his job with a certain monthly salary and earns a fixed increment every year. If his salary was $7,500 after 4 years of service. And $9,000 after 10 years. Of service. What was his starting salary? And his yearly and the annual and what is the annual increment? Okay, so let S be his starting salary and I be this annual increment. And so he starts with some starting salary, and then after 4 years of increases, he has a salary of $7,500, whereas let's call this R1 and R2. And so, whereas he has a starting salary, and then after 10 years of increases, he is making $9,000. Okay, so let's just subtract these. And so R2 minus R1 so let's add these together. And so I have 6i is equal to 1,500. Let me divide both sides of my equation by 6. And so I is equal to 250. And so let's look at R1. S plus 4 times 250 is 7,500. So S plus 1,000 is 7,500. Subtract 1,000. So S is 6,500. So the starting salary $6,500 with an annual increase of $250. And that is your answer. Okay. Let me do problem number 30. two trains start from two stations (1,050 miles) apart. And travel toward each other. They pass each other after 6 hours. Find the speed of each train if one train is 25 miles per hour slower than the other. Okay, so let's do that. So again, remember, distance is rate times time. And so I have two trains. I have a slow one and a fast one. So I guess I'll do slow and fast. Okay. And so after 6 hours, the slow one goes 6s miles. I'm doing this rate in miles per hour. And the fast one takes 6s, goes 6s miles, and it's got to be a total of 1,050 miles. We also have that the slower train, so the speed of one train, the slower train, is 25 miles per hour slower than the other train. So faster train, L, faster, faster. And so the slower train is 25 miles per hour slower than the faster train. Okay, so let's, maybe I'll actually simplify the first equation just to make it nicer. Maybe I'll actually just divide everything by 6. And so S, the slower train plus the faster train, is 1,050 divided by 6, 175. And so maybe I'll substitute in. And so R2, it gives me S, which is F minus 25, plus F is 175. Combine like terms, so 2F minus 25 is 175. Let me add 25 to both sides of your equation. And so 2F is equal to 200. Divide both sides of my equation by 2. So F equals 100. Okay. Well, S by R2 S is equal to F minus 25, so S is 75. And so one train goes 100 miles per hour. And the other train, 75 miles per hour. Let me do problem number 32. A man going at the rate of 5 kilometers an hour in still water takes 3 times as long well, 3 times as much time in going 40 kilometers up the river as in going 40 kilometers down. Find the rate at which the river flows. Okay, so let's do that. So again, distance is rate times time. So a man rows, so 40 kilometers. Okay, so let's say that the current is C kilometers per hour. Okay, and so let's see, he's going 40 kilometers upstream, and so his rate is 5 minus the current, and it takes him T to go 40 kilometers. Okay. S. Now, going downstream, it takes him 3 times as much going upstream. So let's say that it takes him T. So going downstream, it takes him T amount of time to go 40 kilometers. Whereas going upstream, it'll take him 3 times as much time. Okay. Because he's going against the current, so he's going slower. Okay, so let's solve this. So let me simplify this first. So I have 15t minus 3t is equal to 40. And I have 5t plus, oops, 3, there should have been a 3ct plus ct is equal to 40. So let me multiply. So let me just write down the first equation. Or actually, let me multiply the second equation by 3. So I get 15t plus 3ct is 120. And let me add that to the first equation. 15t minus 3ct is 40. So let me add these together. And so I get that 30t is equal to 160. Divide both sides of my equation by 30. So I get that t is equal to 16/3. Okay, that's fine. So now let's plug into, maybe I'll do to r. And so I have 5 minus c times 3t is equal to 40. Well, the 3's cancel. So I have 16 times 5 minus c is equal to 40. Let me multiply the 16 inside. And so I have 80 minus 16c is equal to 40. Subtract 80 from both sides. So I get negative 16c is equal to, negative 40. Let me divide both sides of my equation by 16. And so negative 16. So I get that c is equal to 2.5. And so we want to figure out the speed of the current. And so the current, well, the river flows at 2.5 kilometers per hour. In the future, we'll actually do this slightly differently, where we can actually solve this equation for t, and then I have t is equal to d over r, and you'll actually get a slightly, well, maybe I'll do that. Maybe I'll do that. Or distance equals rate times time. So let me divide by r. So it says that time is distance over rate. Okay, and so we have a distance of 40 kilometers. Okay, and this will be the time that the, let's say the the person is going at normally rows at 5 kilometers an hour. And so if he's going, let's say, upstream, he'll be rowing against the current. Whereas if he's going downstream, he'll be helped by the current. And the time is 3 times as much when he's going against the current. And so you'd have 120 over 5 minus c is 40 over 5 plus c. It's a similar sort of equation like what I've done here, but just slightly in a different fashion. So the river, let me just check. So he's going against going with the current. It takes him 3 times as long as against the current. Oops, I think I actually wrote it the wrong way. Let me just check here. So he's going, so it takes him, if he's going with, so this is against the current, this is upstream, and this is downstream. So he's going downstream, he's going faster. Here he's going slower. So it should take him 3 times as much time to go upstream as it is to go downstream. Sorry, made a wrong equation there. Then if you cross multiply, you would get 40 times 5, 200, plus 40c is equal to 200, I'm sorry, 5 times 120, 600 minus 120c. You would subtract 200, add 120c to both sides. So you would get 160 C is equal to 400. Oh, which I believe is the exact same thing I got here. Well, almost. And divide by 160. And so you're going to get C is equal to 2.5. And so you get the exact same answer. Just done in a slightly different way. Actually, it's probably, in this case, it probably is easier to do it the second way than the first way, but they're very similar. Okay, let me do, let's see, was it problem number 34? The population of a town is 50,000. If in a year the number of males increases by 5%, and females by 3%. The population would grow to 52,020. Find the number of males and the number of females presently living in the town. Okay, so let me do this. So let M be the number of males currently in the town, and F the number of females. So the number of males plus the number of females is currently 50,000. If I increase the number of males by 5% and increase the number of females by 3%, there should be 52,020 people. Okay, so actually, let me say it this way. If I have a 5% increase in males and a 3% increase in females, then I should have 2,020 additional people. In this case, we'll have a slightly smaller numbers. So let me multiply by 100. So we get 5m plus 3f is 202,000. 202,000. Let me multiply by, let's say, -3. So we get -3m minus 3f equals negative 150,000. And so let me subtract. (5m minus 3m is 2m. 202,000 minus 150,000 is 52,000. Let me divide by 2. And so m is 26,000. So plug it into R. I get the number of males plus the number of females is 50,000. Let me subtract 26,000 from both sides. And so F is equal to 24,000. Okay, so at present time, there are 26,000. Oops, what did that say? Let me just check something. Okay. Maybe not. So at present there are 26,000 males and 24,000 females in this particular town. Okay. Testing. Oh no, that's certainly I can. Okay. Uh, Let me do problem number 36. A man travels 600 kilometers to his home, partly by train and partly by car. He takes 8 hours if he travels 120 kilometers by train and the rest by car. He takes 20 minutes longer if he travels 200 kilometers by train and the rest by car. Find the speed of the train and the car. Okay, so distance equals rate times time. So if he goes by train, so suppose he goes t kilometers per hour going on the train and c kilometers per hour going on the car. Okay, good. So it takes him, so the total distance is 600 kilometers that he's going to have to travel. It takes him 8 hours if he travels 120 kilometers by train, and the rest by car, well, that will be 600 minus the 120 to 480 kilometers by car. Whereas if he travels 200 kilometers on the train, the rest by car, well, the rest is going to be another additional 400 kilometers because it takes him, because there's a total of 600 kilometers. It takes him 20 minutes longer. And so 20 minutes is an additional third of an hour. So 8 1/3 hours. Okay, so let's do this. Actually, maybe I'll do it this way. So I'll say that time is distance over rate. I'll maybe write it that way. Okay, so the distance that he travels is 600 kilometers. Well, so the time that it takes him to travel this first way is, well, he goes 120 kilometers at t kilometers per hour, plus he goes an additional 480 kilometers at c. That should equal 8 hours. That's one equation. Next. Well, if he travels 200 kilometers at t and 400 kilometers at c, that should take him 8 1/3 hours, which is 24 plus 1 is 25 over 3 hours. Okay, good. So now let me get rid of one of these. Let's say, let's multiply the first equation by 5. And so I get 5 times 120, which is 600 over t, plus 5 times 480, 2400 over c is equal to 5 times 8, 40. Let me multiply by -3. So I get -600 over t minus 1200 over c is equal to a -25. And let me add these together. So if I add these together, well, the 600 over t's cancel. 2400 over c minus 1200 over c is just 1200 over c. $40 minus 25 is just 15. It is just 15. And let's cross multiply. So let me write this as 15 over 1. And let me cross multiply. And so I get 15c is equal to 1200. Let me divide both sides of my equation by 15. And so I get that C is equal to 80. And let's figure out what T is. That's a nice number. Oh, maybe I'll do R. And so R says 120 over T plus 480 over 80 is equal to 8. Okay, good. Okay, so 480 divided by 80 is just 6. Let me subtract 6 from both sides of my equation. So I get that 120 over T is equal to 2. Let me multiply both sides of my equation by T. And so I get 120 is equal to 2T. Divide both sides of my equation by 2. And so T is equal to 60. And so the train I'll say 60 kilometers per hour for the train. And 80 kilometers per hour for the car. And that is your answer. Okay. Let me do problem number 38. In a 2-digit number, the sum of the digits is 13 if the number is subtracted from the one obtained by interchanging digits. The result is 45. Find the number. So we have a 2-digit number, and let's call the place value for the tens digit T and for the ones digit W. Then the sum of their digits is 13. Next, if I take the number this is my number, subtracted from the one obtained by interchanging digits. So the ones digit goes in the tens place and the tens digit goes in one place. Then the result is 45. So let's simplify this. So I get 10W plus T minus 10T minus W is 45. So 10 T minus 10T is a negative 9T. 10W minus W is 9W. is 45. Let me multiply the first one by 9. And so I get 9t plus 9w is 9 times 13, 117. And let me add. Okay. So let me add these. And so I get 18, the 9t's cancel. 9w plus 9w is 18w, is 162. Divide both sides of your equation by 18. And so w equals 9. And so I have from R, t plus w is 13. Subtract 9 from both sides. And so t is equal to 4. And so the tens digit is 4 and the ones digit is 9. So therefore 49. The number is 49. So notice that the sum of the digits for 49 is indeed 13. And if you take 49 and subtract it from the number obtained by interchanging the digits, well, if you interchange the digits, you get 94. So notice that 94 well, maybe I'll just sort of say it this way. Note 9 plus 4 plus 9 is 13. And 94 minus 49 is indeed 45. And so the sum of the digits is indeed 13. And if the number 49 is subtracted from the one obtained by interchanging the digits, 94, then the result is indeed 45. And so we've found the correct answer. And so that finishes off section 4.5.